And that is why heat pumps just don't work in this scenario. Do you want to see what that is? What's that? Oh, yes! If this is what I hope it is. Radiator fans. These are the fans for the cooling video we were doing the other day. You know, we're going to test the radiators to see if we can increase the output.
Oh, those are the fans?
Yeah, so...
do you want to sit them to the side with, and we'll... No?
I want to do it now, because I've been waiting for... Oh, you have to beep that one out. I've been waiting for these for ages, so can we just do this now?
Yeah.
Ah, brilliant. So, what have we got? You got yourself a DC power cord, box, some interconnecting cables, and some fans. Cool, it's the most fans I've ever had.
So people should subscribe, right?
Funny you should say that, Harrison. Yes, people should subscribe and click on like. Well, this has come as a pack of 3. You can buy them as a pack of 2, or you can buy them as a single one, and then you can keep extending them to go for as large a radiator as you want.
And it all runs off of one power supply.
All runs off one power supply. What I don't know is, I think these might, these might only turn on when they get a flow temperature or a certain, heat come to them. So I'm hoping that's not the case, and they'll just turn on when we want them on. Oh, they're just on. And because these are DC, I don't even know if it's just because these are DC. These just don't have a lot of current draw, so it's going to use barely any energy whatsoever.
How loud is it? Can you hold it up to your microphone?
You have to put your ear on it to hear it. So these clip on the underside of a radiator, but obviously if you're cooling and there is a potential for condensing, which there shouldn't be because we should be setting our flow temperature below dew point. In theory, they could get dripped on, but I'm willing to take that risk to just muck around and see what we can get. Well, it's quite powerful. Cool. Do you think if I strapped enough of these to my back, I could fly?
What's the brand on these? Who makes them?
Speed Comfort. Not heard of them before. Just got these on Amazon. They're all over the internet, to be fair. So this little extra dongle here goes in that other little port that I wasn't too sure what was for. Goes in that little extra port there. And this is magnetic. These have actually got some magnetic strips on them as well. I guess that's what holds them in place, these little magnets on here. And I guess this is a temperature sensor to see when the radiator's on. So if I plug this in, I wonder if this turns them off. Yes, it does. Right, that's interesting. So this is like a bimetallic strip that when the radiator's hot, I mean, I might even be able to heat this up with my hands. It could turn them on, actually. Or maybe even my breath. What's hot? You got a lighter? I think I'm just putting a lighter to this for no reason now, because it might not be a temperature sensor. You can open this as well. So let's see what's in this little sensor. Oh, that could be good. If we can reverse this bimetallic strip, we might be able to wire it so it comes on when they're fed with cool water. Oh, thank you very much, Matt. Matt's just bought me Matt's just bought me a mug of warm water so we can try and see if we can get it to activate. So, as you can see from this camera, this one, the first one, the chain's still running. You may be able to see it in the camera, I don't know. And then where we plugged in the remote, it stopped the next two. If you can see there, this is just a bimetallic strip. Bimetallic strip is where there's two different types of metal which expand and contract at different rates, and then as it warms up, it will. Two bits of metal stuck to each other that expand and contract at different rates on the temperature, and when it heats up, it'll bend to one side to make contact, and when it cools down, it'll bend the other way to disengage. So we might be able to open this up. I probably should have unplugged this really before. I mean, it's only DC, so it's not really that dangerous. I might be able to rewire this so it makes and breaks on cooling. Then we've got fans we can leave in place. They'll never come on throughout the year, unless we want them to. And then when cooling comes on, bang, we've got convector radiators. Is that roasting hot, yeah? Oh, well, let's...
Just fresh out.
Fresh out the can. Right, let's have a look. Let's see how Right, this is 78 degrees. Matt, I cannot drink this. It's ridiculous. It's 82, 83. There we go. Fans are on. Amazing. This is a make or break signal. So actually what we could just do is wire in a switch, an on-off switch here instead, on the wall that you go
Do it manually.
cooling on, cooling off. Or we can get a switch live from the heat pump.
You could just take that out and then
Well, yeah,
turn
that,
it on and off the wall.
yeah, turn it on and off the wall. Yeah,
Yeah.
that's probably.
Yeah, that's probably the easiest.
Rather than wiring a
What an intelligent young man you brought with you. All right, let's go. I've had a shower in here this morning because I use the gym, and because of that, the humidity's rose in here. Therefore, the dew point is higher, and because the dew point is higher, we're getting more condensation and actually dangerous amounts of condensation. So if you have a look down here, all of this condensation, that's going to make the radiator rust. So this needs to be either warmer or off. So it might not be a good idea to cool bathrooms via this method. Even if we set the dew point to 12 degrees, when the humidity rises, dew point might be 16 or something. So, okay, another lesson learned. When you cool with radiators, turn the TRV off. Going to turn it back on now, for the experiment. Right, before I turn that on, watch out because that's live and it's wet in here. Health and safety first. Let's see what this radiator's doing. So, oh my god. All the cold from that radiator is entirely at the bottom of the radiator. The top of the radiator is 25 degrees, which is room temperature basically. The bottom of the radiator is, let's go to the flow, this is obviously the flow. 14, 15. So we've got a delta T from top to bottom of 11 degrees, which was the point and the issue, or 11.5, which was the issue that I said last time, that as the flow comes in, it just stays along the bottom. And if you remember, I also said if we connect fans, it should hopefully kind of spread that up the whole thing, but more importantly, stir the air in the room. This is really wet underneath, like, this is not good. So we might blow something here because these could get wet. Could just put these on top.
It's got to blow the cold air up though, hasn't it? So they've got to go on the bottom.
It's no different.
No?
I can't see any difference because it's going to suck the cold air up. It's still going to move the same amount of air. Don't want them to fall off though. And also kind of want to see how this connects.
Oh!
We're going to fit two on here. At the bottom of the radiator we have 14.9 is the lowest I got. The top of it is 25.5. Now, when Matt turns on the power, take it away, Matt. Or Harrison. Fans turn on. Because this is low output, because the radiators put out less energy than is really required by the heat pump's probably going to be cycling quite a lot. So because these are stripping more heat out the heat pump, hopefully the heat pump will cycle less and we'll be able to get more cooling power from the heat pump, i.e. more power rejected in the form of heat from the property. We're so rock and roll.
You wait till you see the shot of you sat in a bathtub.
So, that's, yeah. Let's really put this on steroids. Everyone in the office, for health and safety reasons, can we not use the bathroom upstairs, please? Actually, we might have to put a sign on here, otherwise we could get sued by the staff.
Sorry, did you say don't use the bathroom?
Don't use the bathroom because you might get electrocuted.
But also, get in it, Adam.
Well, I wouldn't expect you to use it while I'm in here, not like last time. That was embarrassing for both of us. Temperature now, 24.1. I think this went up to 24.3. We may have shaved 0.1 of a degree off here.
I have to say, I'm feeling cooler.
I'm feeling cooler. The thing is, I can feel air movement.
I can feel a breeze just sitting down here.
Even though it doesn't like feel like anything.
Yeah, there's
and the other
definitely
thing
movement.
is, air movement in a room does make you feel cooler because you get a boundary layer around your body, and if you remove that boundary layer, you feel cooler. That's why even blowing hot air at yourself, or the circulating at the same temperature air around you, does cool you down. So maybe this is doing something. I just thought of a way to make this slightly better as well. What we can do is, because there's no air moving up the back of this radiator, so maybe we stagger these. No, like this. That's going to drag some up the back as well. Okay, it's even dragging a bit around the front end. I think that's, oh wow, look, that's, put your hand here. That's moving more air, isn't it?
Yeah, massively.
Right, that's it. Because now, look, like I said before, we're not in series. We're in parallel, side by side. So now we're literally shifting twice the volume of air. So we could actually, no, if we double on the bottom, we're not shifting twice the amount of air because they're in series. It's the same amount of air. It's the same as water plumbing. Learning all the time. Great, let's chuck these in here, shut this door, remember the temperature before we go, which is 24.2, and we'll do the same test in that room in there. And in the hallway, it is, because this is the temperature of the whole building, 22. This has had that aircon in, which I turned off about 2 hours ago, so the walls might be cooler in here. This is my office, looking a little bit messy. Lob a load of fans underneath.
I reckon so. Let's go completely overkill in here.
Same thing. Just chuck all the fans around this radiator. Yeah. We put that other fan at the other end of the room, completing the circuit. So it's shifting all the air around the room. So actually, we can literally just chuck this on the desk. Yep. Nothing but net. So me and Matt are ignoring the instructions, and because we've got one plug socket. Oh, hold on. Yeah. Good idea, Matt. So instead of putting it in one socket, we're putting it in 4. We'll just put this into there, yeah? Is that what we're saying? Right. Yeah. So it's not coming out one socket. You can't use one socket for these, so we're using 4. Via an extension, plugged into an extension. These use 0.5 of a watt. So we're not going to be starting any fires here today. But we're going to be cooling the place. This is £900 fat. How much did you spend? £900.
How much were they for one box individually?
These were £135 including VAT, £115 excluding VAT. Right, so there's 4 underneath. Let's put these 4 pointing in. Use the little magnets.
I mean, this is so overkill, but it will just see, won't it?
And almost with no interruption, almost completely invisible to the eye, you get this vastly improved radiator output for cooling.
So just to clarify, we've got 14 of these on this one radiator.
14, okay, good. 15 degree flow, the top of the radiator's 18.5. Okay, so it's already cooler at the top of this radiator. 19. So, target flow temperature 12 degrees. So we've got it on 12 degrees, which is really above dew point. Yeah, it's condensing. Let's go and see. Oh, I also didn't turn on the extractor in the bathroom. When you use the bathroom and shower, you usually use an extractor, or you should open a window. Otherwise, you get mold and condensation issues. Anyway, let's see what the dew point is today. Oh, 14 degrees C. Oh.
So you got the flow rate too low.
Yeah. The dew point, well, this is great. The dew point the other day when we checked was 9. It's shot up to 14. It varies quite a lot, which I don't normally look at this sort of stuff, so it's good to, I suppose we should look at a graph. So actually, if you're just going to set one dew point, you should be setting it higher. Hopefully we can get this to track the dew point at some point when we work out how to make it automatically run.
It's high humidity today.
It's high humidity, that's the problem. Well, slightly humid on here, 68%. Yeah. That's indoor humidity. External humidity is 72. Let me just go and check the pipes in the other rooms, see if they're also humid, condensing. Oh, let's do the kitchen. Yeah, look, see it running. So, don't do that because that's really bad. Do you know what? For the purposes of the experiment, let's just let it condense. But really, so I've got the flow temperature set to 12. Really, it should be set to 14. But we're willing to make that sacrifice for you, the viewer, and the industry, and climate change and the polar bears.
A few moments later.
It's 3 o'clock. What time are we? About 11. So 4 hours.
11.
Well, that's halfway through the day. So you'd hope it would cool down halfway through the day from when you put them on. So this is a good time to check.
Good.
Right, cool. Do it. You can do the trumpet music. You can leave that bit in. 11 p.m. 24.2. Predictions? I think 23.6. Oh. All hail the heating king to 3.6. Which is...
No one's going to believe that you haven't seen that.
Yeah.
So it's dropped 0.6 of a degree. Great.
That's worth it.
So the conclusion to our experiment is should we go into the office?
Yeah, so
Do you want to make an estimate? So we've got 22.7.
I'll go 21.8.
21.8, so he's saying 0.9 degrees.
I reckon it's gone up.
I think so too. So I'm going to say 22.7 and you think 23 or above.
Yep.
Ready? Got a little cool draft. 22, it's dropped 0.7. So if you go crazy on the fans, and this is a very unscientific, I mean, I'm sure there's other things at play here and drafts and whatever else. But really, we're talking the square root of naff all, aren't we, regarding temperature change?
We did have the sun on this window though after we started this experiment.
We did, well, I think around 1 o'clock the sun gets over to the other side, so that that had 2 hours before it would have got any sun. So yeah, it may have got a little bit cooler if
It's
it didn't
not
have
been a
sun.
massively sunny
But it's
day.
not like you've got air conditioning. You have not got air conditioning if you install radiators with the cooling chip.
No.
You'd have to repipe it so you get the whole effect of the radiator.
Yeah.
Then I think there would be a difference.
And it's the fact that there's 14 fans on that.
14 fans on
14
something that,
times 3.
yeah,
Because there's 3 fans.
14
per
sets
one.
of 3 fans. So, and it would normally have how many? 1, 2, 3, 4 probably. And it's got 5 on top instead of 4. So,
We might just hit a bottleneck with it, to be honest.
yeah, exactly. I think we have, because like I say, it's not increasing flow rate really.
There's a lot of condensation down there.
Oh, is that on camera?
Yeah.
Good.
There's no condensation down here at all.
Is it really bad?
Yeah, look.
Oh yeah. Oh my God, Harrison, can you get on this?
Oh wow.
Oh, let's also bear in mind, with this, we've run well below dew point. Dew point today was 14 degrees. We've run this at a 12 degree flow temperature purposefully for this test. So you wouldn't even, if you were running this above dew point,
I mean,
this would be running at about 15 degree flow temperature. We would have got no cooling at all. This has removed more. This has made the building more comfortable just by removing the humidity from the air than it has cooled the building air temperature in any sort of way. The other thing that we checked was the hallway temperature, which didn't have any cooling, was at 22. That's gone up 1.5 degrees. There's nothing to say that the other rooms wouldn't have gone up by a similar kind of amount throughout the day, which this prevented. So maybe it did do a little bit more than we thought, but we're still not talking, well, we're not talking game changing at all, but it definitely prevented the temperature increasing, which it has done in the hallway. We're going to save these fans because they cost £950, and we're going to install them in the summer and see how much it reduces the weather compensation curve by. By reducing the weather compensation curve, you'll increase efficiency and increase your SCOP. If we haven't posted that video by then and you can't find it, tag us in the comments and we'll make sure that we send a little link to it, put it in the description. In summary, can you use the reversed heat pump through your radiators to cool you down? Yeah, if you lean against it, if you put your feet up on it, it's like a nice thing to touch, lean on, whatever. Regarding if you could just put in the cooling chip and you've got a cooling system in the summer, not really. Like when it was like 32 degrees or whatever, was it 35 degrees yesterday, you're not even going to shave 1 degree off the building temperature, I don't think. So, especially when you've got solar gain, which this wasn't even a solar gain day. If we had solar gain, these rooms would have 100% gone up.
Yeah.
So this doesn't work. If you were to make this work, there would be a way of making this work. Swap these radiators for convector radiators, or we could put a little baffle inside the radiator that would force the water up and around. Then you get some kind of circulation and the whole thing would kind of work a bit better. Or if you've got on the floor, it will work. On the floor you'll get, much more of the output. Again, I don't know how much it will work. We will do an experiment on that though. I think lots more people have done this with underfloor heating anyway, to be quite honest, and they'll probably testify how much it does work. This is kind of like a fun, playful episode. If you want more information on how to cool with a heat pump and ground source or air source and the kind of theory behind it and the technicalities, look out for our how to cool with a heat pump technical kind of video where I chat to Richard and we go a bit more into a deep dive about the technicalities and practicalities of cooling with these systems and avoiding condensation. So I think that's it for this one. Do air source heat pumps work with radiators in cooling in the summer? For us, absolutely not. Subscribe, hit like, see you in the next one.